relative motion analysis, velocity and acceleration, right? At the end of this lecture, you should be able to resolve the velocity and acceleration of a point on a body, the components of translation and rotation. Okay. So translation means linear velocity and linear acceleration. No. And linear acceleration again has two components, that is normal and tangential. And yeah, for translation alone. Then for rotation, you have angular velocity and angular acceleration.
For rotation will be angular velocity and
For sorry, for rotation, angular velocity and angular acceleration.
okay, sir.
And for translation, we have linear velocity in meter per second.
Linear velocity, okay, sir.
Let me write it down here.
Okay.
So first translation, no.
Okay.
So for translation, we have linear velocity. Okay.
Okay.
So
Okay, sir.
unit of this is meter per second.
Yeah, correct.
And then we have linear acceleration. Okay.
Linear acceleration. Okay.
Acceleration unit is meters per second square.
Second square.
Now in this acceleration, again there are two components, two types. One is
Tangential and normal.
tangential and normal.
Norm.
Yeah. Both
Yeah.
of them have the same unit. Both of them have the same
Okay.
unit. Okay. So
Okay, sir.
both of them have the same unit, meter per second square. All
Okay.
this together we can call it as translation. Okay.
Translation. Okay, sir.
All these are for translation. Now for rotation, when we come to rotation, what do we have?
We have angular velocity and angular acceleration.
Acceleration. Angular velocity, what is the unit?
Angular velocity or
Radians
radian per
per
second.
second. Then
Okay.
angular acceleration.
Acceleration.
What is the unit?
I think radian per second square.
Radians per second square. What is the notation for angular velocity? Notation for angular velocity
Uh,
is omega.
alpha omega.
And angular acceleration is alpha.
Alpha.
Okay. So here for
Okay.
linear velocity we use v.
V.
For acceleration we use a. For tangential acceleration we use at.
A.
For normal
T. A.
acceleration
N.
an. Okay.
A. N. Okay,
On the
sir.
left side we have the notations. In the middle we have the name of the quantity. And on the right we have the units.
Yeah, sir.
Okay. Is this clear?
Okay. Yeah.
So this is what we have. Next, determine the velocity and acceleration of a point on the body using relative motion analysis. Okay. We should be able to find velocity of any point on the body. Okay.
Any point of the body.
On the body.
On the body.
So what is this? A wiper blade. Okay. So you have seen the wiper blades on the cars, buses, and all four-wheelers, right?
Yes.
It will be wiping the water from the glass, right?
Yeah. Yeah. Yeah.
So this is he has given the mechanism here. So it is almost like a
Okay.
4-bar mechanism.
Okay.
The wiper assembly consists of multiple linkages. What method can be used to get desired wiper blade motion and its velocity with specific input speed of the motor? So these are the kinds of questions we ask in this subject. Okay. And we try to find the answers to these.
Okay.
Then here you can see this is a mechanism, right?
Yeah.
So any point on the mechanism has translation motion. So for the slider,
Translation motion.
you know,
Okay.
any point on
Okay.
the slider will be
Yeah.
translating. It will be just moving in a straight line, you know.
Yeah. Yeah.
And when you take these two links, link AB and BC,
Okay.
AB and
Rotational.
BC, any link on the mechanism has rotation motion.
Rotational movement.
Okay.
Yeah. Okay.
And then the point C, this is a frame, fixed frame. So this is the fixed
Okay.
point. It does not move. It does not move. Okay.
Yeah. Some. Yeah.
Then here, when using the relative equation, A and B should be generally points in the body with a known motion.
Okay.
Okay. For example, point A on the link AB must move along a horizontal path. Point B on the link BC moves tangential to the path. Okay. So A and B, the
Okay,
motion
sir.
is well defined now.
A and B.
A and B, for both these, the
Yeah.
motion is well defined.
Yeah. Yeah.
A will always move in horizontal direction and
B will move.
B will always move in an arc. Right?
Yes, sir. Yes, sir.
Motion of those two is defined. That's what he's telling.
Yeah.
Once this is the situation, then we can find the velocity of any point on the object by using relative velocity method. Okay.
Okay.
Here the
Okay,
first
sir.
equation is given. Velocity of B
Okay.
with respect to C. Okay.
Velocity of B with respect to C. Okay.
We had learnt about this. That is equal
Yeah.
to velocity of B minus velocity of C.
Yeah.
Velocity of C is constant, no? It's 0.
Yeah.
So we get
Yeah.
velocity of B with respect to C as equal to
Velocity of
VB only.
C is 0 is because it's
It's a
fixed, right,
fixed,
sir?
yeah, it's a fixed point.
Yeah. Okay.
Then thus VB equal to VBC or just VB. So
Okay.
VB is the absolute velocity.
Actual velocity. Okay.
And the link BC, it's rotating with an angular velocity omega BC. This value is given to us.
Okay.
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 If the velocity of angular velocity of BC is given, then we can find
Okay.
linear velocity of B.
Yeah.
That is omega BC into radial distance
Yeah.
BC.
Radial distance.
And here we are proceeding to find the velocity of slider.
Okay.
So velocity of B with respect to A. Velocity
Okay.
of B with respect to
B.
A. Let me take a snip
Okay.
of this. Lead the diagram as well. Take along with the diagram. Sure. Okay.
Okay.
So here we are interested in velocity of B with respect to A. No?
A.
This
Okay.
is equal to velocity of B minus velocity of A. Correct?
Okay. Yeah, correct, sir.
So if we send this to the other side, if you send this to the other side,
With positive.
what happens? Velocity of B equals velocity of B with
Plus
respect to A plus
A
velocity of
plus
A.
A. Yeah,
Correct?
correct.
So that's what he has written here.
Oh, so basically this question is we have to define the question, is it? So define the
Define the
all these links and all of
yeah,
the
we should know the relations. First thing is to know the
okay,
relations. Then some
okay,
data will be given. From that data, we have to
okay,
find the other data.
okay,
So if you are given the velocity, linear velocity, if it is given, you can find
okay,
angular velocity.
okay,
And if angular velocity is given, you can find linear velocity
yeah,
because they are interlinked. Okay.
okay,
As soon as you define any one motion, all other motions get fixed.
okay,
That is the definition of a mechanism. Okay.
Okay, sir.
So in technical terms, we say that it has a single degree of freedom or mobility. Mobility is 1 or
Okay.
degree of freedom is 1. Okay.
Okay, sir.
So
Okay.
degree of freedom is 1 means at a time, at any given time, we can control only one link.
Okay.
Two links cannot move independently. Okay.
Okay. Okay.
Link AB rotates with angular velocity omega AB. This is okay. Uh, okay. AB is also rotating at some angle, no? Angular velocity omega.
Yeah. Yeah.
That he is writing it as omega AB. Okay.
Okay.
That
Okay.
omega AB gives us the velocity of B with respect to A.
Yeah.
Okay. So this is
Okay, sir.
related to that omega BA into RBA.
RB.
Okay.
Okay, sir.
So now AB length is known.
Okay.
This is not known. VBA, is it known?
PBA,
Velocity
no,
of
because we don't know.
B with respect to A. VB minus VA. VB is known now.
Yeah.
VB we just now found. VB minus VA. VA is not known.
Okay.
So VA. Mhm. In this equation also, if you see closely, VB is known.
Okay.
Omega BA is not known. RBA is known. Velocity of A is not known. Lots of unknowns are coming. Only if there is only one unknown, we can find the value, right? Here VBA is
One
known, no?
and yeah.
Velocity of
Yeah.
no, velocity of B with respect to A is not known. Velocity of B with respect to C is known.
Yeah.
But this is also unknown. In all of them, we are
Yeah.
getting two unknowns. So it's a
Yeah.
bit difficult to define here. But maybe he's just trying to explain it. When we solve a problem, we will understand it perfectly. Okay.
Okay.
Let's go to the next example. So here we have wheels. Okay.
Okay, sir.
So in the wheels, if the total wheel is moving in forward direction without rotation, okay,
Okay.
can you imagine
Can,
all the
sir. Going
points?
forward
Yeah,
direction.
there is no rotation happening in the wheel.
Yeah. Yeah.
Every part of the wheel is going forward. Okay.
Yes. Going straight. Okay. Yeah.
And here, what's happening? There is no
It's
translation.
rotating.
Upper point is moving right side, lower point is moving
Yeah.
left side.
That's right. Yeah.
So when we add these two motions together, we will get the total motion. That is the rolling of the wheel.
General key. Okay.
When the wheel rolls, the
Yeah.
velocity at the bottom is 0 because it is in contact with the ground. Correct?
Mm.
The center point
It's
will,
linear. It's linear center. It's
sorry,
instantaneous center. Is it instantaneous center? No.
it is the
The down
instantaneous
part.
center. Yeah, the contact
Okay.
point is instantaneous center and its
Okay.
velocity is 0 because it is
Okay.
in
Velocity
contact
is
with the
zero.
ground. You know?
Down. Okay.
So how it happens, because you can see this velocity is forward, here the velocity is backwards.
Okay.
So when we add these two
Okay.
velocities,
It will
positive
be
and
zero.
negative will cancel,
Yeah.
leaving us 0.
Okay. Yeah.
Whereas in the center, you can see
Yeah.
translation is having some velocity, rotation
Yeah.
center is fixed, center is not moving.
Yeah. Yeah.
So some velocity plus 0, we get some velocity, same velocity. You know?
Okay. Okay. Sir.
And at the top, what is happening? Both the velocities are in
Yeah.
same direction,
So they
so
have
they will
two
add up.
velocities.
They will add up.
Yeah.
Okay.
Okay.
So this right side motion is called as pure rolling. Called as pure rolling.
Right. Pure rolling. Okay.
Okay.
Pure rolling. Okay.
If it is not pure rolling, there will be some slip happening at the contact point. Okay.
Okay.
If the slip is happening, then velocity v will not be 0.
Will be not zero.
Okay.
Okay, sir.
Let's see the next one. Okay, relative motion analysis. So he is again giving the equations, same equations which we already are aware of. So next, he is explaining the procedure for analysis. So velocity analysis. How to do velocity analysis? The first step is to establish fixed xy coordinate directions and draw the kinematic diagram of the body, showing the velocity vectors VA, VB, RBA, and omega. If the magnitudes are known, the sense of direction may be assumed. What do you mean by sense of direction?
Sense of direction.
Let us say we know that velocity is acting in a particular direction. Okay.
Okay.
But it can be in forward direction, right direction, or left direction. No?
Yeah, correct, sir.
So
Correct.
this is called as sense.
Sense.
Forward or backward is called as sense.
Sense.
Okay. The angle,
Okay.
the angle of this is called as direction. This is called as direction, and the arrow mark is called as sense.
Sense.
The sense can be forward or backward.
Backwards.
Forward or
backwards.
okay.
Okay, sir.
Direction has to be angle of a line.
Angle of the line. Okay.
Then express the vectors in the Cartesian form and substitute them into the equation. So these are basic steps. If we once solve a problem, we will come to understand. And now here he is defining the cross products. What do you mean by cross product? There are two products when it comes to vectors. Vector multiplication has two types. One is called dot product. The other is called cross product. Okay, let us understand that. Vector multiplication. Vector multiplication. Okay.
Okay, sir.
Let us say A and B are two vectors. A and B are two vectors. Okay.
Okay, sir.
So let's call A as A1I plus A2J plus A3K. Okay.
Okay, sir.
The vector B, let us write it as B1I plus B2J plus B3K. Okay. So this A1, A2, A3, B1, B2, B3, they are all constants. Okay.
Okay, sir.
A1, A2, A3, B2, B1, B2, B3 are constants. Now dot product. Dot product. Yeah. So when we are finding the dot product, it is written as A dot B. Okay. And A dot B is given as A1 B1 plus A2 B2 plus A3 B3. Okay.
Okay.
This is the dot product.
Okay.
And here the dot product, we must remember I dot I is 1. Okay.
I dot I is 1. Okay, sir.
Then J dot J is
I think I did this in maths,
1.
I guess, sir.
Sorry, ma?
I think I will do this before.
You have read this before?
No, I then earlier, very long ago, so I think in maths or somewhere I've done this.
Yeah, it will be there in maths as well. Okay, maths is actually the language of physics or mechanics. Mechanics is a part of physics, of course, right?
Okay.
So there will be repetitions. We are in mechanics, we are trying to apply the maths. In maths, we just learn to solve the problem. In mechanics, we learn to apply it to practical situations. I dot I is 1, J dot J is 1, K dot K is 1. Okay.
Yeah.
Any other combination is 0.
Combination is 0. Okay.
Okay. Any other combination means
dot product,
let's say I dot J is 0.
Okay.
J dot K 0. K dot I 0.
Okay.
Okay,
Okay.
so this
Okay.
is how the dot product operates.
Okay.
Okay, so that is why what we get is a1I dot b1I. I dot I will get now.
Okay.
I dot
I
I
dot
becomes
I
1
one. Okay.
and a1 b1 we are left here.
Okay.
When we multiply a1I with b2j, we get I dot j now,
I dot J. Yeah, correct.
and I
That means
dot j
zero.
is 0. 0 into
Zero.
anything is 0 into anything is
Zero.
0. No?
Zero.
Then if you
Yeah.
multiply
Yeah.
this with this, again we get I dot k. I dot k
Okay.
is again
Zero.
0. 0 into
Zero.
anything is
Zero.
0. Understood?
Yes.
This is how the dot product operates. Okay.
Okay.
Now let us understand cross product. Let us understand cross product. Ready?
Okay, sir.
So cross product is written like this: A cross B. Okay.
Okay, sir.
And here we have to apply some set of formulae. Okay. The formulae are like this: I, J, K. Okay.
Okay,
So
sir. I J K.
if we cross multiply I with J, then we
Okay.
get positive. I
Okay.
cross J is positive.
Positive. Okay.
J cross K is positive.
Positive. Okay.
Okay, J cross K is positive I. I cross J is
Positive I.
positive K. J dot K
Okay.
is positive
I.
I. K dot I is positive J.
K. Okay.
So if we are moving in clockwise direction, the result is positive.
Okay. Okay. If no, it's negative. Is it,
But if you move in anti-clockwise direction, that means if you have K dot J.
okay.
Okay, so let's first write the positive. I dot J is
Okay.
plus K. J dot K
Okay.
is plus I.
Plus I.
Okay, then K cross I. K cross I is positive J.
K J.
But J cross I. J cross I,
K
now we are
cross.
moving in this direction, anti-clockwise.
So that means it'll be positive K.
Yeah, we get negative K here.
Oh, negative K. Oh,
Okay, when we are
okay.
moving clockwise, it is positive. When we are moving
Positive.
anti-clockwise,
Oh,
okay,
negative.
negative.
Okay.
So again here, if we do K cross J,
Okay.
K cross J is
K
again
cross
anti-clockwise, no?
is negative. Negative I.
Negative I. Then I dot K, negative J.
I J. Negative J.
Now what about I cross I?
I cross. Not. Zero. One.
I think it's 0.
Oh. Oh.
I
Okay.
cross I
Okay.
cross I is 0.
Zero.
Now J cross J is 0.
Zero as well.
K cross K is
Zero.
0. Got it?
Got it, sir.
So this is how we need to do the cross product. Okay. Now if you want
Okay.
to do cross product, you have to expand this. I, AI, A2J, A3K. Okay.
Okay, sir.
This cross product with B1I, B2J, B3K. Okay.
Okay, sir.
When we take the cross product, multiply this with this, you know,
Okay. Yeah.
and then first with second, you know,
Yeah.
and first
Then
with
first with
third.
third. Yeah. Correct.
So then second with first, second with second, second with third, you know.
Yeah.
And for all these we need to apply. Okay, conveniently.
Okay. Okay.
Okay. Okay.
Okay, sir.
So that is what he is explaining. So I dot J, you can see he is writing K. Okay. I cross J. I cross J is K. J cross K is I.
I.
K cross I is
Okay.
J.
J.
If you are moving clockwise, it is positive. But if you are moving
Positive.
anti-clockwise, it is negative.
Is negative.
Okay.
Okay.
Next, once again procedure. We have gone back.
Okay.
This is over. Okay. Now we have a example. Ready?
Okay. Okay, sir.
Okay. So okay. Example one. Okay.
Okay, sir.
Crank OA rotates with angular velocity. So angular velocity of OA is given, right?
Yes, sir. Oh, yeah. Correct.
And this is omega, right? Omega of OA.
Omega of OA.
Omega OA is given, right?
Yeah, correct.
Velocity of the piston B and the angular velocity of AB, we have to find it. Okay.
Okay. Okay, sir.
So velocity of how do we start? We have to start with velocity of A. Okay.
Okay.
Velocity of A will be omega of OA into
Times radius.
radial distance
Radius.
OA. Correct.
OA. Okay. Yeah.
Omega OA is known, that is 12 radians per second into radial distance is 0.3 meters. Right.
Okay. Yeah.
So
Okay.
multiply them. What do we get? We get 3.6.
'Yes, sir. Correct.
3.6 meters per second. Okay.
Yeah.
So that is velocity of A, absolute velocity of A.
Yeah.
Then slider will be moving upwards. Okay, this is the velocity of B. Okay,
Yes, sir. Okay.
then velocity of A with respect to B, how will that be?
Velocity in respect to B. That means is it moving?
Velocity of B we need to find. Okay. So let's do it by this instantaneous center method. Okay.
Okay, sir.
What is the instantaneous center for VA and VB?
BA and BB. So,
VA, from VA we have to draw perpendicular. Okay.
yeah, correct. Yeah,
And for
down.
VB also we need to draw perpendicular. Okay.
Yeah, correct.
So both of them are meeting here. So this is our instantaneous center. Okay.
Yeah, okay, sir.
Now we should take this instantaneous center and find it. So about this
Instantaneous.
instantaneous center, whatever omega is there, that omega will remain same.
Will
Okay,
be equal to it, sir. Okay.
that omega will be equal to VA
Okay.
times OA, है ना?
Yeah. OA.
VA times OA or divided by ना?
No, divided. Yeah, because radius
Divided by,
is
yes,
half, right, sir?
radial distance OA. Okay, so divided by radial distance OA. Okay, and it is
Yeah.
also equal to VB divided by OB, radial distance OB. Correct?
OB. Okay, sir.
Now we know the value of VA, है ना?
Okay.
We know the value of OA also,
Okay.
and we know the value of
We know
OB also.
OB. Yeah.
So can we find VB?
Yeah, can.
Yes. So substitute them all. What
Okay.
happens here?
Mm,
So
VA is
VA is how much? 3.6
3.6,
divided by OA. OA is 0.3.
0.3.
VB. VB
So
is
the
not known.
medium is the
VB is not known. Keep it as it is.
okay.
Our OB. OB is how much?
0.6, sir.
OB is this length, not hypotenuse.
Oh, okay. So we have to find, right, so
Yeah.
six
So let
point
us call it as X. How to find X?
zero point 0.6 square minus 0.3 square. It's
You can use
no,
Pythagorean relation also. You can use 0.6
we
square
can't. We
minus
got tangents
minus 0.3 square
0.6
under root.
square. Yeah,
What do we get?
0.3. 0.12, 0.52, sir.
0.52
52.
after taking
Yeah,
square root.
yeah,
Okay. And next, so this value we have to use here. Okay.
yeah, yeah.
0.52. Now find VB.
Maybe.
VB will be equal to, this will go up, है ना?
Yeah.
Multiply this and divide by 0.3. What do we get?
3.3.
Get 12 into 0.52. What do we get?
6.24, sir.
6.24 meters per
Yeah,
second. Okay.
yeah,
This is the velocity of B.
yeah.
The velocity of B. Okay.
Okay.
So velocity of B, we found it. Next, we have to find omega AB. है ना?
Omega is basically, yeah,
Omega AB. Omega AB will be equal to velocity of A with respect to B divided by radial
okay,
distance AB.
okay.
Okay.
Omega, yeah,
Velocity
so correct.
velocity of A with respect to B. A velocity of A with respect to B will be velocity of A minus velocity of B, no?
Yeah, correct.
Divided by radial distance AB. AB length is 0.6.
Yeah.
Now VA
VA
minus
minus VA
VA and VB both
3.3.
are vectors.
Yeah.
Both are vectors, no?
So 3.6 minus 6.24 is it?
But one is in I direction, the other one is in J direction.
Yeah, correct.
Let us see what he has done here. Up. So he is finding the velocity of A. Velocity of A, you can see it is in X direction, right? We found this correctly.
Yeah, sir.
We didn't write it
Yeah.
as I, but okay, it is understood. Next, he is finding,
So why is velocity if A is negative, sir?
because it is moving in left side, no? Opposite to X direction.
Oh, okay.
Opposite to X direction, that's why minus 3.6 I. Then velocity of B 6.24. Huh? How much did we get?
So this question must to use the
Yeah, 6
IJK. Is
point.
it?
Velocity of B also we got correctly.
Yeah, correct.
And
So this question we have to use the IJK. Is it?
IJK we have to use here. So I'm using the other method. He's showing with IJK method. What is he doing here? K and J. Oh. Now I understood. So here all of these we have to use in vector format. Okay. So first
Yes.
let us define the vectors. Okay, let's keep this aside. Okay. All of these we have to write in vectors. So because it is
Okay.
in this direction, that means anti-clockwise now.
Okay.
Now use the right hand rule and tell me what is the direction of omega
It's towards us.
towards us, right? So towards us
Yeah.
means in z direction, correct?
Yeah, in that direction. Yeah. That's right.
Z direction. So z direction means omega of OA. Omega of OA equals ijk now. So 12k.
IJK.
Okay.
12K. Okay.
Omega OA should be written as 12k. Then OA
Okay.
radial position
Because it's
position
okay, it's
vector.
in K direction.
Ama?
IJK because oh, it's in Z direction.
Yeah. So radial distance OA. OA is in which direction? Y direction, no?
OA.
This is Y direction.
Yeah. Yeah.
This is X direction. No? So
Okay.
ROA can be written as 0.3 times
0.3.
IJ. Correct?
IJ. So it will be
I is X
0.3.
direction. J is Y
Okay.
direction. K
Yeah.
is
K is
Z
Z
direction.
direction.
Because this is Z direction, है ना?
Okay.
Z direction. That's why we have taken K. This one is in Y direction now.
Okay.
Because it is in Y direction, we have taken J.
That's why it's K. That's it.
Now when we want to find velocity of A, we have to do cross multiplication. What we have to do?
Cross multiplication.
Cross multiplication. But which one should be taken first? First we have to take omega OA cross product ROA. Okay,
ROA. Yeah.
you know the cross product, right? 12k
Yeah.
cross 0.3j. What is k cross j?
K cross K is 0.
IJK. If we
Oh,
move in
IJK.
if
Okay.
you move in clockwise direction, it is positive now.
Positive. Yeah.
So kj, are they in clockwise direction?
K to J is it? No.
It's
Anti-clockwise.
anti-clockwise now, so it is minus.
Yeah. Negative 5.
So the answer is minus 12 into 0.3 is
3.
3.6
3.6.
and k cross j is minus I.
Yeah.
So that minus we are getting here.
Oh.
Okay.
Okay, sir.
This is the velocity of A. Same way, what has it done next? We use graphical method over here in India, so I'm not conversant with this. Next, velocity of A is clear now. Next, we have
Yes,
to
sir.
take VB. How we will get VB formula? Velocity of
VB is equal to
velocity of
omega
let's first write
V.
velocity B with respect to A. Okay. B with
Okay, okay, sir.
respect to A will be velocity of B minus velocity of A, right?
Okay, yeah,
So
correct.
we are interested in VB. So send
VB.
this to the other side.
Okay.
When we
So
send it,
positive.
so it becomes positive. So VA
Positive.
plus VB with respect to A equals VB. You know,
Okay, sir.
we can just write it as interchange LHS RHS. VB equals VA plus VB plus A, B with respect to A. Right.
Okay. Okay,
So
sir.
that is the formula
Okay.
is given here.
Okay.
Now velocity of B. What is velocity of B?
Velocity of B is
Velocity of B, we know it is
three.
vertically upwards, you know,
Okay.
but we don't know the value. So let's write it as
Yeah.
velocity of B multiplied with
Yeah.
y-axis, that is J.
J. Okay.
So this is equal to velocity of A. Velocity of A, we found it now just now. Velocity of A is
Yes.
minus 3.6 I. Correct.
Minus 3.6. Ah, yeah.
So
Correct.
velocity of
Velocity
B with
of
respect to A. Velocity of B
A.
with respect to A. This one is complex. Velocity of B with respect to A.
Yeah. Yeah.
Okay, so here velocity of B with respect to A will be perpendicular to this, है ना?
Okay.
It will be perpendicular to the link AB.
You
Got
mean
it?
the angular velocity with
Velocity of B will be vertical. That is absolute velocity. है ना?
okay. Okay.
But
Okay.
velocity of B with respect to A.
Okay.
Velocity of B with respect to A. That means when A is kept constant and we see the velocity of B, it will be perpendicular to this, no?
Perpendicular. Okay.
Correct?
Perpendicular to
Perpendicular to
the link
AB.
is it so?
Perpendicular to
Okay,
AB.
the link. Okay, sir.
Perpendicular to
The
AB.
AB rod. Okay.
And this angle is 30 degrees. So what will be this angle? It will be 60 degrees.
Yeah. Yeah. Because
And
it's
this
90.
component we have to find. This component will be VB into sine 60. Yeah.
VB VB sine 60. VB sine 60 is because it's on
Mm.
it's sine is because of y is it
For this is taking the two components, not that angle. We have to take this angle. Okay, this angle is 60 degrees. Okay,
okay.
so velocity of B with respect to A is like this, and its angle is 60 degrees here. So what will be the two components?
Okay.
X component and Y component. X component will be VBA cos 60 now,
Okay. Oh, 60. Yeah.
and Y component will be
VBA
VBA
VB sine 60.
sin 60. Now this is X direction, so it is multiplied to I. This is Y direction, so multiplied to J.
Okay.
Okay,
Okay, sir.
so VBA can be written as VBA into cos 60
Okay.
times I,
VBA cos 60.
now
Okay.
plus
Okay.
VBA into sin 60
Okay.
into J.
G. Okay.
That is what he has written here. Okay,
Okay.
this VA we have taken here, VA value we have taken, VBA can be written as this plus this. Okay, Then we are equating the I and j components. We are equating I and j components. So left side and right side we want to compare. Okay, how to compare?
Okay, sir.
So here if you take I common, we get minus
Okay.
3.6 plus VBA cos 60, है ना?
Yeah.
Plus if you multiply j will be multiplied with v with respect to a into sine 60. Okay,
Okay. Okay.
now this is multiplied to j now,
Yeah.
vbj. So whatever is coefficient
Okay.
of j here, same will be coefficient of j here now.
Okay. Okay, sir.
That relation we can use, or we can use the coefficient of I coefficient doesn't exist now, so the
Okay.
coefficient of I is 0 here.
Okay.
So that we can use. So compare it. So 0 will be equal to minus 3.6 plus velocity b with respect to a into cos 60. Okay.
Okay. Okay.
Send the terms to the other side. We will get velocity b with respect to a. What do we get? This becomes positive first, and this goes down cos 60. Correct.
Okay. Yeah. Correct, sir.
It implies that velocity of b with respect to a is equal to how much?
The velocity of
3.6 by
PA equals
cos 60 is 0.5 now.
yeah,
0.5. 3.6 by 0.5. 7.2.
7.2. Yeah.
7.2 meters per second.
Yeah.
This is velocity of b with respect to a.
Hey.
Velocity of b with respect to a. Clear?
Hmm.
So next we have to compare the coefficients of j. Coefficients of j.
J.
What is the coefficient of j on left side? That is just VB. No.
Okay.
What is the coefficient of j on right side? B with respect to a into sine 60. No.
Yeah. Correct.
So if you compare this now, which values are known? Just now we found the value VB with respect to a. No.
PB respect to A. Yeah.
Substitute that
Correct.
here. We get 7.2
Okay.
into sine 60. Sine 60 is root 3 by 2. Okay.
Okay.
Calculate this value. What do we get?
7.8. 8.82, sir.
8.82.
Yeah. 8.82 meter radian per second is it?
6 point divided by 2. 3.12 no ma?
Oh,
Check it.
I think 6.2, sir. 6.24.
Oh, 1 minute. Yeah, 6.24 no?
Yeah, sir.
6.24 meter per second.
No, meter per second. Okay.
This is the value of B. Okay.
Mhm.
With our previous method also we got the same value, right?
Yeah, sir.
It doesn't matter which method you use, you should get the same result.
Oh,
Okay.
so regardless method, so we can use any method, is it, sir?
Yeah. So
Okay.
in India here we teach graphical method. By graphical method we mean we usually draw the velocity diagram.
Oh, free body diagram, is it, sir?
Not velocity. No, it's not like a free body diagram. We call it velocity diagram. So we
Velocity diagram. Okay.
what we do is we draw velocity of a,
Sir.
and its
Okay.
length is proportional to the value of velocity.
Okay.
Then from A, we draw a line which is perpendicular to AB.
Perpendicular to AB.
This line is perpendicular to AB.
AB. Yes,
Okay.
sir.
And then
Okay.
we draw a vertical line from here.
Okay.
This they will both intersect here now.
Yeah, correct.
This length will give velocity of B.
Velocity of B. Okay.
These points will be A and B.
A and B. Okay.
Now if you want velocity of B with respect to A, it will be pointed this side. Okay.
Okay.
And if you want velocity of A with respect to B, it will be pointed downwards.
Okay, sir.
So this is called as velocity diagram.
Okay.
This is what we teach, and I think your college prefers the vector method, so this is how you could do it. Yeah. I think probably they want you to use this because this method can be used in programming. Okay,
Oh.
because you can make these equations in MATLAB or Python or any other
But
language.
it's very complex, right, sir?
It is complex, but it is easier to program.
Oh.
Computer cannot understand graphics, right?
Yeah, correct, correct.
Even if you draw the graphics, then you have to convert that diagram into equations. That becomes very tough.
Okay.
I think that is the reason why your university prefers this. Here in India, we don't use coding much. Fine.
Okay,
We
okay,
allow the students to use drafter and other geometric instruments, or
okay,
we allow them to use AutoCAD or such software.
okay,
That's the reason we go with graphical method.
okay,
Graphical method allows us to do analysis of any component. Fine. But here you can see this is much simpler position. The angle is 30 degrees. Here we have 90 degrees. You know.
okay. Yeah,
So if the position changes, if the angle is not 90 degrees, then analysis becomes
yeah.
very much more complex.
Oh,
Okay. So both of them have their
okay,
own plus points and minus points. Okay.
okay,
So
okay,
it's all it finally it all comes down to which method you prefer. Okay.
okay, sir.
Your university prefers this method, so you have to go with that.
Yeah,
Then finally we have to find velocity, angular velocity of B with respect to A. So we know this relation. Velocity of B with respect to A, we found it.
yeah.
We also know the length of AB.
Okay,
So we can use that to find it. Okay.
okay, okay,
Once again, he is taking that also in IJK format.
okay, okay,
Take it in the same format.
okay,
Okay.
okay,
Here you can see K cross I. K cross I.
K cross
IJK.
I.
K cross I should be negative now.
Yeah, K cross I. Yes, correct.
And K cross J. IJK.
K cross I is positive,
K
right?
cross
No,
I is positive.
positive J.
K cross I is positive. Give me a minute. Nano?
Okay,
K cross I is
positive.
positive. K cross J is negative.
K cross J. Yeah, correct. Negative I.
You just need to write this equation down. From here we get this equation. Then again finally we have to compare I and J. Okay. Coefficient
I
of I
and J.
we have to compare with coefficient of I. This side. Okay.
Okay, sir.
And comparing them, we can solve for omega BA. That is the only unknown here, right?
Yes.
You get it. Any doubts here?
Okay.
Any doubts here, ma'am?
What's it?
So is this clear, or do you want me to explain this?
Yeah. I understand, sir. Because the radial distance, right? Oh my God. Because the,
जाना भी रेडू दे क्या करे 2 मिनट आई क्लास yes ma'am. Let's go for the next one.
okay, sir.
Okay, so here once again we have a slider crank mechanism, right? So he is calling it as the shaper mechanism. We have one slider here, one connecting rod, and one crank or rocker, you can say this.
Oh,
This is the usually made use of in shaper machine. You know what is a shaper machine?
no, sir.
Shaper machine, you know, it's a machine which moves to and fro and used to do the machining.
Okay.
So if you have a block like this,
Okay. It will shape it.
if you want to make a groove in this, that's right.
Hmm.
Like this,
Okay.
if you want to make a groove in this, okay.
Okay. Okay.
So there will be a tool, and this tool will be sorry, it's attached to a ram. This ram will be moving backward and forward, okay.
Yes.
And when the tool touches this surface, it will remove the
Okay.
metal layer by layer.
Yeah. Yeah. Yeah.
So this machine is called shaper machine.
Shaper me.
Okay. And
Okay.
to move this ram, we will be using the mechanism. So this mechanism is used for moving the ram. Okay.
Okay. Okay.
So the shaper mechanism is designed to give a slow cutting stroke and a quick return to the blade. So here what happens is in forward motion, metal is removed. No,
Whole motion. Yeah.
when
Correct.
it is moving forward, metal is removed.
Yeah. Yeah.
But when it is moving back, no metal is removed.
Yeah.
Metal not
Oh,
removed.
yeah.
Okay.
Yeah. Okay,
So
sir.
for removing metal, more force is required. No, more force
Move
required.
fast. Yeah. Correct. Correct. Correct.
And for moving back, because no metal is removed, less force required.
Yeah. Less fast.
So that is why backward motion happens quicker. And forward stroke
Quicker. Okay.
happens slower.
Fast. Slower. Okay.
Okay,
Okay, sir.
that is what he is telling here in this statement. Uh,
Hmm.
is it telling designed to give a slow cutting stroke? The forward stroke is called cutting stroke
Okay.
because metal is removed, and a quick
Okay.
return. Quick return means backward stroke is quick, means faster,
Okay.
to the blade attached to the slider. So blade means I called it as a tool. So this tool he is calling it as blade.
Okay.
So the blade moves forward very slowly, but it moves back very
Okay.
fast.
Okay.
That is how the motion happens. The
It's
link
written to a
AB is
blade. Okay.
rotating. So rotation speed of link AB is given. Okay. This link
Okay.
AB is rotating at 4 radians per second.
Okay.
And what is he asking? Find the velocity of slider block C. So we have to find velocity of the slider block.
See.
This new page. Okay, let us start. So velocity vc equal to how much? So if it is moving this side, this will be moving left side, right?
Okay, yes,
This
sir.
is
Correct.
velocity of c,
C. Okay.
and this is moving in anti-clockwise direction, and the velocity will be like this, right? This
Anti-clockwise is it, sir?
is anti-clockwise. So velocity of b
Okay.
will be like this, perpendicular to the
Yeah, perpendicular to
AB.
the AB.
Yeah,
Okay.
perpendicular to AB. If this angle is theta, then this angle will also be theta, right?
Which that angle? Yeah, correct.
Theta equal to 60 degrees. He has given the value of theta also 60 degrees.
Okay.
So here also this will be
Okay.
60 degrees. Okay.
Okay, sir.
So this is got by geometry. Okay.
Okay, sir.
How you might ask? This is right angle triangle, no?
Okay.
This angle will
Oh,
be
okay.
30
Now I
degrees.
understand.
Okay. Then this is 90 degrees. So this will be again 60 degrees. Okay.
60. Okay.
So that angle is 60 degrees. So how to find, how to define VB? VB, if you, okay, VB, okay, with vertical the angle is 60 degrees. So if you want x component, what will be x component? X component will be minus
VB.
VB into sine 60. है ना?
Science. Science. Okay.
This is x component,
Oh,
so
yeah. Correct. Correct.
multiplied with I.
Correct. Correct.
Then y component will be VB
It's
into cos
cos.
60 multiplied
Yeah.
with j.
J.
So this is upward, so it is positive. Okay.
Yeah.
So this is VB. Then RAB, we need to find RAB also. No?
Yeah.
What is RAB?
RAB is
This,
300
yeah,
mm, sir.
300 length is given, but that 300
Yeah.
length is inclined. No? So
Incline.
we have to find x component and we have to find y component. Again, we have to write in IJ format. Ready?
Okay. Okay, sir.
So RAB. What is RAB?
RAB is 300, right, sir?
Comma?
Or we have to write it's 300. No.
300 cos 60. If you take, you will get horizontal. No?
Okay.
300 cos 60
300
will give us horizontal.
cos.
Horizontal means multiply to I.
Okay.
And then vertical. For vertical, it is opposite of 60 degrees. So sine. 300
Fine. Okay.
into sine 60. This is
Sine 60.
vertical,
Okay.
so multiply with j. And because it is upwards, we have to make it positive.
Yeah.
Then same way, omega AB. What is omega AB? Omega AB is
Omega
anti-clockwise.
for,
Use
yeah,
right hand rule.
anti-clockwise.
Use right hand rule to define direction. Is it I, J, or K?
Okay. It's, I think, I, right? K, right, sir? No.
K, yeah, because it is in Z direction towards us, no?
Yeah. Yeah.
Because it is towards us, we have to write it as 4K. Okay,
Okay. Okay, sir.
all three are defined. Now we can multiply them. So what is the relation? Relation is VB equals omega AB cross
Okay.
product radial distance AB. Okay.
Okay. Okay, sir.
Omega AB is how much? Omega AB is 4k. No. Then cross product with RAB. RAB is this value. No.
Sir, Omega AB is given 4 radian digits, sir.
Sorry.
Yeah, 4 radian, yeah, correct. Okay.
This voltage here.
Okay, then that is that. Okay.
Now multiply. K cross
K cross I is
I J K.
cross
Clockwise is positive.
Sir.
So positive
J.
J, no? 4 3 is a
Yeah,
12. Cos 60. Cos 60 is how much? 0.5, no?
yeah, 0.5.
Cos 60 is 0.5. So 0.5 means half. Half of 1200, 600.
600.
600 K cross I is positive J. You know?
Yes, sir.
And then again sine 60. What is sine 60? It is root 3 by 2. Root 3 by
3 by 2.
2. If
Root 3.
you
Root 3 by
do, let's take root 3 here, and by 2, let's cancel with this 150. 4 into
Okay.
150, how much? 4 into 150 is again the same, no? 600. 600, no?
Yeah, yeah, correct, sir.
600
600
root 3 J. Oh,
J.
sorry, not J.
J. Okay.
K into J. K cross J is minus I.
J. Yeah.
Minus means you will get minus here. Okay.
Mm.
Clear?
Yeah, yes, sir.
And here VB, if you substitute on the left side,
Okay.
VB, if you substitute on the left side,
Okay, sir.
this side, it's going outside. Okay. Yeah. So if you equate these two, now you
Okay.
will get the you can compare now. Okay.
Yes, sir.
Compare I with I, coefficient of I, J with coefficient of J. Okay.
Okay.
So I component we have minus VB sine 60 is equal to I component is here minus 600 root 3 I. I will be gone anyway because we are comparing coefficients of I.
Okay.
You know?
Okay.
So sine 60 is root 3 by 2.
Three by
Root
two, okay.
3 will cancel. This 2 will come in numerator. This minus becomes plus. So VB equals this 1200 now.
Okay.
And unit, what will be unit? This is mm.
Yeah.
Mm and radians per second. You know? So
Radian per second is it, sir?
we will get mm, no? Mm per second we will
Yeah.
get.
Okay.
So if you want to convert this to meter per second, you have to divide it by 1000. Divide by 1000, you will get 1.2 meter per second.
Meter per second, yeah.
This is the value of velocity of B.
B.
That is the velocity of
B.
B. Okay.
Velocity of B.
Next. Next. Okay. Let's next write down the relative velocity formula. Okay.
Okay.
Velocity of B with respect to C. Velocity of B with respect to C will be equal to velocity of B minus velocity of C. Correct?
Okay. Yeah, correct.
So velocity of C we have to send to the other side. We get
So
velocity of
plus.
B equals velocity of B with respect to C plus velocity of C. Correct?
Yes, sir.
So velocity of B. How to write velocity of B? It's like this now.
Velocity of, yeah.
So it will be minus VB. VB is 1.2.
Okay.
1.2 sine 60
Of
I plus again VB. VB is 1.2 cos 60
Okay.
of J. Correct?
Of J. Okay, sir.
This is equal to velocity of B with respect to C. Velocity of B with respect to C will be again perpendicular to this now.
Okay.
Velocity of B with respect to C will be perpendicular, and for this again we need to find the two components, x and y components,
Okay, sir.
because this angle is 90 degrees, the other side is 45, so this also will be 45. Right?
Correct, sir.
Now write the value. So velocity of B with respect to C, horizontal component, no? Horizontal component is cos 45
Okay.
into I, because it is forward, and plus velocity of B with respect to C cos sin 45. Okay, J. Correct?
Correct, sir.
So this is velocity of B with respect to C. Then plus VC. VC, we know it is in horizontal direction and it will be backwards, right?
Okay.
So we have to take it
We see.
as minus VC and
Okay.
I, because it is in X direction. No?
Okay.
Hmm. Again, combine the I and J terms. I term, if you take, you get velocity of B with respect to C into cos 45 minus VC. No?
Okay, sir.
And if you take J terms,
45.
J term we have only
Okay.
one, that is velocity of B with respect to C sin 45. Correct?
Okay. Yeah, 745. That's right.
Now compare the I and J terms. Compare, first let us take J terms. Coefficient of J.
Okay.
Coefficients
Okay.
of J. So
J.
1.2 cos 60. The right side
1.2 plus 60.
we get velocity of B with respect to C sin 45.
Okay. Okay.
Velocity of B with respect to C will be 1.2
We
cos 60. Cos 60
okay.
is how much? 0.5.
Cos 60 is 0.5.
0.5 divided by sin 45. What do we get?
Okay.
1.2 into 0.5 divided by sin 45.
0.849 is it, sir?
0.849.
Yeah.
0.849 unit meters per second.
Meter per second. Okay.
Now we know velocity B with respect to C. Next we have to compare coefficients of I.
Okay.
Coefficients of I.
Alright.
So for I, left side I is minus 1.2 sin
Okay.
60, and right
Okay.
side coefficient of I is this total, right?
Yeah.
Velocity of B with respect to C into cos 45 minus VC, right?
Okay. Okay. Correct, sir.
Velocity of B with respect to C we can substitute here. Okay, we get
Okay.
velocity of VC. This term comes this side, 0.849 into cos
Okay.
45, and this term comes the right side, plus
Okay.
1.2 sin 60. Do this, you will
Okay.
get it.
So we have to, sir. Okay.
0.849 into cos 45 plus 1.2
1.63.
1.639, so 64, 1.64 we can take.
Yeah.
1.64 meters per second.
Yeah.
Okay,
Okay, sir.
is it the same? Yeah, it is the same. Okay,
Okay, sir.
so 0.85 we got the same.
Yeah.
1.64 we got the same.
Yeah.
Okay, then for acceleration you have to differentiate. Acceleration is also asked, huh?
Okay.
In this question, has he asked acceleration?
No,
Only
only the velocity
only
here.
velocity. Then why is he doing acceleration?
Yeah.
So this is the next topic starting. So he is explaining how to find acceleration. Okay.
Oh, yes.
So similar to velocity equation, we will also have acceleration equation.
Okay.
So the what is that? What is it called? Subscript. Subscript values are same. You know. Here also
Okay.
you have B. Here also we have B. Here B with respect to A. B with respect to A. Here A. Here also A. Right.
Yes, sir.
Take the velocity equation and just
Okay.
replace
Okay.
V with A.
A.
Replace V with
Yeah.
A. You will get acceleration.
Yeah.
Okay. Then
Yeah.
VBA can be substituted like this. Is substituting VBA by omega BA
Okay.
into RB with respect to A.
Okay.
That term he is differentiating. That term he is differentiating. Okay.
Okay, sir.
So when he differentiates that term, he will get two terms for velocity of B with respect to A.
Okay.
One well, sorry, one value is tangential velocity, tangential acceleration.
Yeah.
The other term is normal acceleration.
Okay.
That's how we do it. Tangential component is writing in detail. Normal component is
Okay.
mentioning in detail. Okay.
Okay. Okay.
Oh, now it's a
It's
4
the
bar.
same.
Hmm?
It's the same from what we learned, right, sir?
You? Sorry.
No, it's the same thing, right? So from
Yeah,
what we learned earlier, so
it's the same thing, but lots of things are coming up at the same time. So it's
yeah.
not so simple. It's much more complex. Okay. We have an example here. The disk is rotating with omega. Omega is given.
Okay.
Alpha is 16 radians per second square at this instant. Velocity and acceleration
Okay.
of collar at A. A is moving horizontal, right? Shall we try?
A is more horizontal. Yeah, correct. Thanks, sir.
Take this, make it this. Is our okay. Start.
Okay, sir.
The disk is rotating with omega 8. Alpha is this much.
Okay.
Velocity and acceleration of collar at A.
Both also angular velocity and angular acceleration, right, sir?
Sorry,
It's angular velocity and angular
this is linear
acceleration
now.
is given.
V means linear now.
Yeah, we have to
So
find now with
omega
linear.
and alpha are given. These are angular values.
Yeah. Yeah, yeah.
These are angular values, but what we have to find, these are
It's
linear
linear.
values.
Yeah, yeah,
Linear
yeah.
values. So let's start. How to start? Again, we have to start at point B. It is moving, rotating clockwise, so the velocity will be perpendicular. Is this? Yeah, it is perpendicular, so it will be in this direction, right?
Okay, sir.
Take a different color. So velocity of B will be in this direction, right?
Yes, sir.
Again, we have to take two components, x component and y component. Okay,
Okay.
ready?
Yes, sir. Ready.
So velocity of B can be written as, before finding velocity of B can be VB. Which angle is known here? This angle will be 30 degrees now.
Yes, sir.
So because that is 30 degrees, horizontal component will be VB sine 30, है ना?
Yeah,
That is multiplied with I. Then VB cos 30 ना?
yeah,
J. Both are positive because right side and upwards, है ना?
yeah.
So this is the velocity B. Then we have to define
Okay.
the vector B to A. Define the vector BA. Okay. What is vector BA?
Vector BA for
He
R
is
is
he has given
five.
the 500, but 500 is inclined, no?
So we have to do the
Vertical and
Pythagoras.
again two components, vertical horizontal, right?
Yes, sir.
So again this angle is 30 degrees. Okay.
Hmm.
So
Yeah, correct.
horizontal x component is sine. So 500 sine
Five,
30
five,
times I. No.
500, 500 sine. Yeah, correct, 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 sir.
Then vertical component 500
Cos. 500
cos
cos
30
30.
times J.
Okay.
This is moving forward and upward, so both are positive again, right?
Yeah, yes, sir.
So you can actually convert this to meters here itself. This is in now.
Yeah, yeah, man.
So to convert into meters, we have to divide by 1000.
How is it?
Last time we had to multiply at the end now.
Yeah,
We can multiply here also. So all this cancels. We get point here, right?
okay.
And zero point
Yeah,
0.5 into sine
yeah,
sine 30. Sine 30 is again 0.5. 0.5. 0.5 into 0.5 is
yeah.
0.25. है ना?
0.25.
0.25
Yeah,
I plus here again 0.25 times root 3.
root 3 of the obviously.
So this is in meters. Here this is in meters per second. Okay.
Okay. Yes, sir.
And now we have to define omega. Omega. Omega, you can see it's rotating clockwise. Clockwise means, is it towards us or away from us?
Turquoise is
Huh?
towards us.
Think again.
Eh,
Yes,
oh no, away from us.
away from us. Away from us means you have to take minus.
Yeah.
So minus 8.
Yeah.
Minus 8. I या J?
Minus, uh, minus 8. Wait a sir. Minus 8. Minus 8. It's towards, it's towards us means it will be K.
Okay.
Yeah.
Z direction, na?
Yeah. If away from us means it'll be,
Sorry.
if away from us, it'll be I, is it, sir?
OB,
No, if it's away from us, sir, it's the angular velocity. If it's Away from us.
Okay, it's away from us. See, for coordinate system also, we have to take right hand
Okay.
coordinate system. If this is x,
Okay.
this is y,
Okay.
z will be towards us or away from us?
That will be towards us.
Z will be towards us. So towards us,
Yeah.
z is positive.
Yeah.
And if it is pointing away from us, we have to take it as negative.
Oh, okay.
Right. So in this case, it is pointing
Okay.
away from us now.
Yeah. So that's why
That's
it's
why we
negative.
are taking
Okay.
it negative.
Okay.
Right. All the conventions
Yeah.
we need to take it correctly. Even if you make a mistake at one place, the entire thing goes wrong.
Yeah. Yeah.
And the advantage with programming is you just have to program it only once. You know,
Okay.
once if you program correctly, then other values you can change and you will directly get the result. You know,
Oh,
that is why many universities teach coding based calculations. Okay, that's why they
okay.
prefer vector method.
Okay.
Omega is over, and more. Now we have to apply the relation. What is the relation? VB, है
Relation.
ना? VB
Okay.
equals VB equals omega
Omega
cross
B R.
BA, right?
Yeah. Yeah.
Now substitute all the equations we found. First is this one, right?
Okay. Yes, sir.
First is this one. Take it as it is.
To the VB.
Meter per second. Let's remove it.
R. Okay.
हे ना बांगड़ा फेंक ले बघ. This is equal to again minus 8k plus one can jump. Then RBA
Okay.
also do it. We found the
RB
simplified
is
equation
0.2. So we have to check.
0.25i
Okay. Okay.
0.2.
Okay. And then,
Okay, correct.
okay. Okay. Correct.
So once again multiply these two and then compare. So
Okay.
k cross
P
I
cross I is J.
k cross I is j. But here we have negative in the beginning itself. That will remain
Yeah.
now.
So it'll be negative. Yeah. Correct.
8 times 0.25, what do we get? We get 2.
8 times 1. Yeah. So 2.
2j. You know?
Yeah. Correct.
And then k cross j anti-clockwise, so minus.
Minus.
So this minus into
So
this
okay.
minus becomes plus.
Positive. So, yeah.
And 8 into 0.25 we get 2 again. Root 3 remains as it
2
is.
is root 3.
K
Yeah.
cross j we get I.
Yeah.
Now again we have to compare coefficients of I. On the left
I.
side we have VB sine 30. Sine 30 is 0.5. And then on the
Okay.
right side we have 2 root 3 I. I know. That's it. Correct?
Yes. Yeah. 2 root. Yeah. Correct.
So VB will be equal to 2 root 3
2 I.
by 0.5.
Oh.
What do we get?
Okay.
4 root 3. 4 root 3 is how much?
4 root 3 root 4. 4 root 3. 6.9293.
6.93.
Yeah.
Now this will be mm per second or meter per second?
Meter per second, sir.
Yes, because mm we already converted here, right?
Yeah. Yeah.
Meter per second. Last time we
Yeah.
got mm per second and then we converted later.
Yeah.
This time we did it before only. Then coefficient, one more coefficient not needed, no? So VB is found, that's it. Coefficient of J we
Okay.
need not compare here because there are no more unknowns here. Okay.
Yeah.
If more unknowns are there, then we can compare J also.
Okay.
So velocity of B we found. Next, we have to write the relation of velocity of B with respect to A, no?
Yeah, sir.
Velocity of B with respect to A. Velocity of B with respect to A is velocity of B minus velocity of A, है ना?
Yeah, sir.
Let us send this to the other side and rearrange it.
Okay.
Velocity of B will
Okay.
be velocity of B with respect to A plus velocity
Plus.
of A. Right?
Yeah. Yeah.
Now once again we need to substitute velocity of B. We found it, no? Equation velocity of B. Velocity of B. How much? 6.93, no?
Yeah.
So we have to write in IJK format.
Yes.
IJK format 6.93 sine 30.
6.93.
6.93 into sine 30. This equation, no?
Yeah.
Or this equation. Substitute in that VB.
PB. Okay.
So shall I take it directly?
Okay.
This equation we have to take.
Yeah.
This equation we have to take. And wherever VB is there,
Okay.
we have to substitute. In
Yeah,
place
sir.
of VB, we have to substitute. What we have to substitute?
Yeah. 6.93.
Hmm. 6.93. 6.93. One minute. Hero, बैठ चलो, बैठ चलो, अरे बैठ चलो, बैठ चलो, मार का तो हालत. Okay,
Okay.
this is equal to velocity of B with respect to A. B with respect to A will be perpendicular to this now.
Yes, sir.
So this is velocity B with respect to A. Correct.
Yeah, correct, sir.
Once again, we need to find the two components. How to find the components? It is perpendicular. This angle is 30 degrees. So this angle will be 60 degrees now.
Okay.
Or you can take this angle as 30 degrees again.
PB. Okay, sir.
Use that.
PBA will be always.
Use
Okay.
that and find both the components for V B with respect to A. So V B with respect to A into cos 30. This will give us
50.
x component. Correct.
X component.
And x component
Yeah.
is
Yeah.
going left side. Left side means negative now.
Yeah.
Multiply it with I. Then VBA
Mm-hmm.
sine 30. है ना?
Sanctity.
This is going upwards.
Yeah.
Upwards is positive. J. Correct.
Yeah. Yes, sir.
This is for
Correct.
VBA. This is for VBA. And velocity of
Okay.
A. What is the velocity of A?
Velocity of A.
Velocity of A will be in x direction. Na?
Yeah.
So we can just write it as velocity of A multiplied with I.
Okay.
And because it is in right side, it is positive.
Yeah.
Okay.
Okay, sir.
So this is our equation. is our equation. So let's write it. Just move it. Sorry, yes. So let's move it and write it here. Okay, fine.
Yes,
From
sir.
this equation, we got this, right?
Yes, sir.
Now here, whatever known values are there, we can substitute. I terms,
Okay.
get them together. J terms, get them together. Then compare the coefficients.
Okay.
That's it.
Okay, sir.
So first, let us compare J terms. So coefficients of J. J
Okay.
coefficient is this one. So
Okay.
6.93 cos 30. No,
Cos. Okay. Yeah.
that is on the left side. Right side, we have this.
Yeah.
Take that. Okay.
Okay, sir.
So therefore, what do we get? Velocity of B with respect to A equals 6.93 cos 30 by sin 30. No,
Yeah.
do it. What do we get?
12.00, sir.
Sorry,
12.00.
12.00. Exactly.
Yeah. Yeah. It's 12. No, not exactly. 12.003111.
Okay, so we can ignore. We can just write it as 12. So 12 unit.
Unit will be meter per second.
Then coefficient of J over. Then next coefficient of I, because there is
Coefficient
still
I.
one more unknown. VA is unknown. No?
Yeah.
So coefficient of I on the left side is 6.93 sin 30, है ना?
Yeah, correct, sir.
And on the right side we have two terms. So this term plus this term we have to take.
So, okay.
Minus VBA
Okay.
cos 30, and this
Okay.
is plus VA plus VA.
Yeah. So now we can substitute the 12.
Yes, yes. This value substitute here, and we get VA. VA will be equal to, this is positive 6.93, sin 30 is zero
Yeah.
point 0.5, and this term also comes to the left side, it becomes positive. So 12 cos 30. What do we get?
So I'm saying
Okay,
13.86, sir.
13.86
86.
meters per
Yes.
second.
Second.
Okay,
Okay, sir.
we found all the velocities.
Yeah.
Velocity of A he had asked, we found it. Okay,
Yeah. Okay.
now we need to do acceleration.
Yeah.
Acceleration is going to be much more complex. Okay, ready?
Yeah, sir.
Oh, acceleration. I'm scared of moving ahead. Acceleration. So let's take another page of this. Shall we do it here itself? Lock this away. Use a different color for acceleration. Okay,
Okay, sir.
we use a red color. Okay.
Yes, sir.
Now with red color, whatever I mark, it will become acceleration. Okay.
Okay.
So uh, or for the point B, there will be two accelerations. No, no.
Yeah. Yes, sir.
So towards the center, we have normal acceleration
Okay.
and tangential acceleration. Okay.
Okay, sir.
So next, let's put the formula. So normal acceleration and tangential. So normal acceleration. So normal acceleration, what is the angle here?
Number acceleration, the angle will be
30 degrees, no? With horizontal 30 degrees. Correct?
okay, sir. Okay.
Okay. So normal acceleration, x component will be cos an
Okay.
cos 30, है ना?
How 30? So it's 30 is towards
With this angle,
the
right?
middle, let's say. Okay.
With horizontal it is 30.
Oh,
Okay.
okay, sir.
So an cos 30. Give me a minute. What? 2 minutes. Hello, you there?
Hello. Yes, sir.
So an cos 30, it's in positive direction, that is x direction. But y direction is downwards, no?
Y direction is down.
Downwards, no? Is it downwards?
What? Wait.
This this acceleration, normal acceleration, I is forward, so it is
Yeah.
positive. Y is
Okay.
downwards, no?
Yeah, correct. Yeah.
Minus an sine 30 of j. Okay, got it?
Yeah, okay, sir. Yeah.
This value, let's take it here. Okay.
Yes, sir.
In same way, we have to write for 80. 80 is acting upwards. Its angle is 30 degrees with vertical. Correct.
Yeah. Alright.
So 80 or horizontal component is cos no, sine, no? Horizontal is sine 30, you know,
Horizontal.
and it is positive.
Sine 30. Okay.
And vertical is cos 30. That is also
Yeah,
upwards.
vertical.
That is upwards. So again, that is positive. You know,
Okay.
these two values we have to move here. We just move these things to the other place. That will be better. All the velocity terms that we defined. This work is over. Velocity we have kept it aside. Accelerations, let's take them out. Okay.
Okay.
Uh, we defined both the accelerations now,
Okay, sir.
and now same way we have to define two more accelerations. This acceleration was for This acceleration was for B,
Normal and tangential. Huh?
absolute B, no?
Okay.
These are for absolute B.
Two.
Okay.
Okay.
Next, we have to find B with respect to A.
B
Next,
to B. So that means B minus A.
yeah, that will again have two components. No, one
Okay, sir.
component will be tangential, one component will be
Okay.
normal.
Okay.
Okay, so no tangential component will be like acting this direction. Normal will be parallel to this. Okay,
Okay.
it's already very crowded, so I cannot show it here. I'm showing it here. Okay,
Okay.
this one is a tangential component of
Okay.
B with respect to A. Okay,
Okay.
this is the normal component of B with respect to A. Okay,
Okay, sir.
so once again, both of these we have to express in this component format. So tangential component B with respect to A is
Okay.
how to write it. I can just put dashes here. I think because writing every time writing B with respect to A becomes very big. No,
Yeah.
let me just put dashes. AT dash and AN
Okay.
dash. Okay.
Okay. Okay, sir.
So once again we need angles here, x
So
and
the
y direction.
A will be perpendicular to the VB. It's a
Perpendicular to BA.
B.
80,
Okay.
80 dash will be perpendicular to BA.
BA.
Okay.
Okay. Okay.
And we are lucky that BA is perpendicular to
Okay.
this length. BA is perpendicular to
Okay.
this length. We are very lucky.
Okay.
If it was
Okay.
not perpendicular, the equations would have been way more complex. Okay.
Okay, sir.
This angle here is 30 with horizontal. Normal AN angle is 30 degrees with vertical. So tangential components AT dash uh,
Okay, there.
minus, because it is going backwards now, minus
Okay.
80 dash cos 30 of
Okay.
I,
Yeah. I
then upwards, so plus 80
plus
dash sin 30
30.
of j.
Okay. Okay.
Then normal component B with respect to A, uh, this is both are positive now,
Yes, sir.
an dash sin 30 I
Okay.
plus an dash cos 30 j. Okay,
Okay, sir.
these are the values. Ooh. And then acceleration of A,
Okay.
acceleration of A, we know it will be in tangential direction only because there will not be any normal acceleration. Huh?
Okay.
It will have only tangential acceleration, and let us call it as AA. Okay,
Okay. Okay.
so AA, if you want, you can write it as AA because it is in x
Okay.
direction. You can just
Okay.
multiply I.
Okay, sir.
Okay,
Okay.
is there anything else? We also need to define alpha, no?
Alpha, yeah, correct.
Alpha, is it clockwise or anti-clockwise?
Alpha is anti-clockwise, sir.
Clockwise, no?
Oh, yeah, clockwise. Yeah.
Both omega and alpha are in clockwise direction, right?
Yes.
Clockwise means away from us or towards us.
Away from us, sir.
Away from us means we have to make it minus
Yeah, negative.
minus 16 radians per second square, है ना?
Okay. Okay.
And into I or J.
Away is K.
16 minus 16k radians per second square.
Yeah. Yeah.
Okay. So now we also have to define this radial position of B. No, position of B
P,
is
okay.
150 mm.
50 mm. Okay.
Uh, but even that is inclined now.
Yes, sir. Then the
So
B is simple.
it's like this, right? B is here. This is our point.
Yeah.
This
Yeah.
length, this length is 150. Yeah.
Yeah.
Let me check the diagram again. Yeah, the radial distance is 150. This distance is 150. Okay.
Okay.
So we have to
Okay,
again
sir.
find x component and y component for this.
Okay.
So this angle is given as 30 degrees. X component
Okay,
will be
sir.
150 into cos 30, है ना? And it is
Yes, sir.
backside minus into I, then
Okay.
plus 150 sin 30 into J.
Okay. J.
So because it is in mm, let us again divide by 1000. When you divide by 1000, we get minus 0.15 cos 30 I, and then sin 30 is zero point 0.5. Zero point 0.5 means we get 75 now. 75 by
Yes,
1000,
sir.
0.075. No?
Okay.
This is RB.
Okay.
So now tangential component. So tangential component is alpha into RB. Correct?
Yeah. Yeah, correct. Normal is
B. Oh, we make a mistake here. VB na. So VB means we cannot take 500 here no.
why?
That has to be 150, right?
Yes, sir.
So we made a blunder here. These velocities are wrong, so here also we get mistake. What is the velocity that they got here in the PDF? Velocity of A, how much?
2.4, sir.
How much did we get velocity? 13.86 we got.
Yeah.
They are getting 2.41. So we made a mistake. Understood?
Yes, sir.
Because RBA I took, no?
Okay.
Because it's not supposed to be A. Because the name of this fixed point, center point, is not given any name, no? Got it?
Mm, yeah.
So by mistake I took AB. AB should not be
Okay.
taken. We should take this length, you know? That length is
Oh,
150. So we made a mistake here. The blunder is this should be 150. This also should be 150. Okay.
okay, sir.
Shall we stop here?
Can sir.
This problem it's very complex, way more complex. And you need some time.
Okay,
We'll continue this tomorrow. Okay.
okay, sir.
Hopefully tomorrow we will complete this.
Okay.
This is the last problem in this PPT, right?
Yeah.
So, yeah, our speed is way fast. It's good enough. So next lesson is 7, no?
Yeah, 7.
So 6 is almost over. Last topic is left out.
Okay.
So because of that one mistake, we got stuck. If we don't do that mistake, I think
Okay.
we will get the result. No problem. Without any problem. Okay.
Okay. Okay. Okay.
Acceleration part becomes more, yeah, much more complex. We will see that in the next class. Okay.
Okay.
We'll stop here. See you
Okay.
tomorrow.
Okay. Thank you.
Okay.
Okay.
Bye.